This is the summary for lesson 13, two graphs for each relationship. So for every proportional relationship, you can always draw two graphs, and likewise, you can always write two equations, one equation for each of those graphs. So in the story for the summary, they have a faucet that's leaking. It's leaking at a constant rate, and every 2 minutes, it leaks 10 milliliters of water. So you can look at that relationship in two ways, the two graphs, the two equations. So one way is to look at it as minutes per milliliter, and eventually you want to look at how many minutes does it take to leak 1 milliliter. You want to get it down to 1 milliliter, but you're going to start with the information given, which is 2 minutes for 10 milliliters. Or you can look at the reciprocal relationship, which is 10 milliliters per 2 minutes, and eventually you're going to want to figure out how many milliliters for 1 minute. You always want to get the denominator to 1, and that's going to tell you what the constant of proportionality is for 1 unit. So 1 unit takes, in this case, how many milliliters? 1 unit, in this case, takes how many minutes? So 1 unit is 1 milliliter, 1 unit is 1 minute. And notice where the y over x comes in. So the numerator is y, the denominator is x. So in this case, y is on the minutes is on the y-axis, milliliters is on the x-axis, and so over here the labels are reversed, whereas milliliters are on the y-axis and minutes are on the x-axis. So these are reciprocals, also called multiplicative inverses of each other. So the first situation is that the elapsed time is proportional to the volume of water. So when you say time is proportional to volume, that means that time is on the y-axis, or is the y-coordinate, and volume is on the x-axis, or is the x-coordinate. So that simplifies to 1/5 minute per milliliter. The beginning information is 2 minutes, is right here. Start out at 2 minutes per milliliter. And if you measure 1/10 the volume, that's 1 milliliter, then it's going to take 1/10 the time. So that's 2/10 minutes. And 2/10 minutes simplifies to 1/5 minute, and that's per milliliter. So 2/10 minutes is 12 seconds. 1/5 of a minute is also 12 seconds. So you can say this is time is proportional to volume. You can also use this word versus. This is going to start to show up. I think it's in the teacher's text. I think that's why I included it here. So it's time versus volume. So time is the y value, volume is the x value, or you can say time per volume. So time again is the y value, volume is the x value. On the other hand, if you look at the reciprocal relationship, that is going to be milliliters per minute. So it's down here. So it says in the text here, it says it's leaking at a rate of 5 milliliters per 1 minute. So if you cut this time in half, instead of 2 minutes, you measure it only for 1 minute. Well, half of 10 milliliters is 5 milliliters. So that's going to be 5 milliliters per minute. And so again, the vocabulary, you can say volume is proportional to time. So volume is going to be on the y-axis, and time, this time, is going to be on the x-axis. Volume is versus time. So we're going to graph volume versus time. So volume is going to be on the y-axis, time is going to be on the x-axis. And finally, you can say volume per time. Volume per time. So volume is the y-coordinate and time is the x-coordinate. And notice that these are reciprocals. 2/10, 2 minutes per 10 milliliters, 10 milliliters per 2 minutes. So they are reciprocals, and then when you simplify them, it's 1/5 minute per milliliter, or 5 milliliters per minute. So 1/5 and 5 over 1. All right, so here are the graphs. Now they're going to introduce a new idea in this case. I don't think this came up in the activities at all for this lesson, but the idea of an independent variable and also a dependent variable. So let's take the situation on the left. This is the volume is being measured. The volume is on the x-axis. So that's being what is being measured. So imagine that you're measuring the amount of water that's leaking out of the faucet, and you ask a friend of yours to tell you how much time it took to measure, let's say 10 milliliters. So you're going to sit there with a little cup and you're going to measure the volume until you get to 10 milliliters, and you're going to tell your friend, okay, how much time did that take? And your friend is going to say, oh, that took 2 minutes. So notice that the volume that you're measuring is independent. There's nothing, it's what you are measuring. So you're going to measure 10 milliliters, and the time is dependent on that volume that you measured. So the volume is the independent variable, the time is the dependent variable. So 2 minutes is dependent on measuring 10 milliliters. Simplify that, you get a constant of proportionality. Again, 1/10 the volume is 1 milliliter, 1/10 the time is 2/10 minutes, which simplifies to 1/5 of a minute. So the constant of proportionality is y over x is 1/5. And so notice that the time is going to be 1/5 the volume that you collect. So if you collect 1 milliliter, it's going to be 1/5 of a minute. 2 milliliters is 2/5 of a minute. So the amount of time is always going to be 1/5 the units of volume. So volume is the independent variable, 10 milliliters. Time is the dependent variable. It depends on the volume that you collect, 2 minutes. So on the right side, now we're going to say time is the independent variable. So now you're going to measure that leak for, let's say, 2 minutes. Okay, you're going to sit there with a stopwatch. You tell your friend, okay, I want you to just collect this water until I tell you to stop. So you measure for 2 minutes. So after 2 minutes, you say stop. And then, okay, how much volume did I collect? I collected 10 milliliters in that 2 minutes. So in this case, the 2 minutes is independent. That's what I'm going to measure. I'm going to measure the leak for 2 minutes. And the volume is dependent on measuring that leak for 2 minutes. So the 10 milliliters is the dependent variable. The 2 minutes is the independent variable. It's independent of anything else, whereas the volume is dependent on the amount of time that you measured that. And as before, if you measure for half the time, so 1 minute, you're going to measure half the volume, 5 milliliters. So this constant of proportionality is 5 milliliters per minute. So it's right here, this 5 milliliters per minute. So in 1 minute, you measure 5 milliliters. 2 minutes, measure 10 milliliters. 3 minutes, you're going to measure 15 milliliters. So the volume, the units of volume are always going to be 5 times the units of time. So the time is the independent variable, and the volume that you measure is the dependent variable. 10 milliliters for that 2 minutes time that you measure the leak. So notice that the units of time are 1/5 the units of volume. So this over here, the units of time are 1/5 the units of volume. That means that it takes a small amount of time, 1/5 of a minute, to measure 1 milliliter. So just in a very short period of time, you can measure 1 milliliter, 1/5 of a minute. So a small amount of time to measure 1 milliliter. So this is a constant of proportionality that's less than 1. This is 1/5 of the volume that's measured, the units of volume. Whereas on the right side, the units of volume are 5 times the units of time. So in this case, it takes 2 minutes to measure a volume. So the volume is going to be 5 times the amount of time. So it's 5 times that 2 to get to 10 milliliters. So it's a large volume that's collected in this 1 minute. So right here, 1 minute, you collect 5 milliliters. So the volume is the units of volume are 5 times the units of time. So 1 minute, 5 milliliters. 2 minutes, 10 milliliters. 3 minutes, 15 milliliters. So you're measuring a relatively large volume, 5 milliliters, collected in 1 minute. So this is a constant of proportionality that's greater than 1. So notice that this slant is much steeper and this slant is much shallower or less steep. And this is greater than 1. This is a constant proportionality of 5. This is less than 1, a constant proportionality of 1/5. Notice that they are reciprocals of each other, 1/5 and 5. And I put together this diagram once again to show you the reciprocal nature of the constants of proportionality. So in 1 minute, how much volume did you collect? Well, you collected 5 milliliters. So that means you're going to start out, the constant proportionality that's greater than 1 is that 5 milliliters per 1 minute. So you're going to divide this circle up into 5 equal parts. And you go around, this is 1 milliliter, 2 milliliters, 3 milliliters, 4 milliliters, and 5 milliliters. How do I know 5 parts? Because I'm measuring 5 milliliters in that 1 minute. That means that if I go around this circle for 1/5 the time, I'm going to measure 1 milliliter. It's 1/5 of a minute per milliliter. So it's 12 seconds per milliliter. Another 1/5 of a minute or 12 seconds, 2 milliliters. Another 12 seconds or 1/5 of a minute, 3 milliliters. Another 1/5, so this is 4/5 of a minute, or 48 seconds, that's 4 milliliters. And finally, when you get to 60 seconds or 1 minute, which is 5/5 of a minute, you measure that 5 milliliters. So again, this takes some time to get used to, but I think it's really worthwhile to try to make this drawing of this reciprocal relationship.